so this is the second half of the acid-base equilibrium video. We got done talking about Kw, and we just got done talking about pH and what pH actually equals. So this equation you use if you're given H plus concentration and you need to get to the pH. What if you are the opposite situation where you are given the p-value and you need to know the concentration? Here's the equation that lets you get there. So you're using not the log, but you're using the anti-log. So H plus is equal to the anti-log of the negative p-value, either pH or pOH. And again, if you're using the Inspire, please do note that you've got directions there. You're going to do the 10 to the x key, hit the negative because you need to do the negative value, and then enter the p-value. So once again, just verify for me that you know what you're doing. So if the pH is equal to 3.5, tell me what the H plus concentration is. So if it's 3.5, you should wind up with a pH of 3.16 times 10 to the negative 4. One other thing to note, if the pH value is 0.5, it's always going to be 0.16 in the concentration. And remember, it's 3.5, so the exponent is 4. The pH is always 1 less than the exponent of the concentration. Okay, so, we're mixing it up a little bit. Now you're given the pOH. We want to know what the OH minus concentration is. You're not going to do it any differently than what you did pH. So you're going to enter the anti-log of the negative pH. So you should wind up with, 1.2 times 10 to the negative 10. Again, double checking. P-value of 9 means concentration should be 1 more than that. Okay, so again, I will give you the equation, but you have to know how to put it into the calculator. If you're using the Inspire, it's a little bit different, so take note of that if you like using your, your 84 instead of your Inspire. So there's equation number 3. Equation number 4 is very easy. You've got pH plus pOH has to equal 14 because 1 times 10 to the negative 7 times 1 times 10 to the negative 7 are your concentrations equals, what's the Kw? 1 times 10 to the negative 14. So p-value, p-value, p-value. So it makes sense. So pH plus pOH equals 14. Last thing I want to do is summarize all this stuff. So this is a nice little visual. I've seen a lot of kids reproduce this on their tests to remember things. But if we want to go back and forth between H plus and OH minus, you're going to use the Kw equation. Just isolate whatever variable you don't know. It works both ways, so the equation is the same for both. Likewise, if we're going, back and forth between pH and pOH, again, pH plus pOH is equal to 14. It works both ways. But when you're going back and forth between the p-value and the concentration, the equations are different. So if you're given the concentration trying to get the p-value, you're doing the negative log of the concentration. So going down, that's what you're using. If you're going up, you're using the anti-log. If you have the p-value, you're using the anti-log of the negative p-value. Oops. So that's just all 4 equations kind of shown there in a nice little organized table. For some of you, visually, it works out nicely. All right, so you got a lot of problem sets to practice doing these equations. So keep track of what you're doing. Think about the little hints that I gave you over the course of the 2 videos. Think about where p-values need to be, right? Low, if you have a concentration that is small, what's happening to your p-value? It's going up, right? You're going from 2 to 3 to 4 to 5. So as the concentration gets smaller, the p-value is going higher. So a low pH means you have an acid. A high pH means you have a base. But if you think about pOH the other way, same thing holds true, but it's opposite here. If H plus is 0.01, pOH, is 1 times 10 to the negative 13. This is 13. And so forth. So keep that in mind. These two are inverse, but these two are also inverse. So as the pH gets higher, the H plus concentration is also getting smaller. So remember this idea. All right, so go do those problem sets, and we'll check them out in class.